We usually start grading with an existing ground surface. Here we see contours for an existing surface. Then we need some line work. Here you can see we've dropped in site boundary, a car park line, and then a building platform at the back. So here you can see how easy it is to manipulate the surface, adding some points to create a retaining wall in this area because the cut and fill is spilling into the next property. And you can see the lines as well, how you can easily regrade those lines. I'm just clicking on that box to create the retaining walls, and that's done. And you can kind of get a sense on the isometric 3D, the model, and how the pads can be changed colors. You can zoom in and out to see what's top right. You can see quantities for cut and fill, which takes into account layer works, which you also can calculate. Then there's also the rates for those items, cut, fill. I've got some retaining wall items in there as well, just to give a sense of the values as you go. Then there's also the actual DXF export. So in DWG, these are the contours you would get. And then for Civil 3D, you can export the XML. You can also export the XML for the other solvers. This is the grading solver. What you need to start with is a surface. So I have a simple surface in here. And it's good also to have some line work. So let's assume in this instance, the architect has given us a layout, say pad 1. Let's call this a building pad. So you can go down here and you can change the name, building. Pad 2, let's call this a car park. Car park. All right. And we can see the site is fairly steep. So just to have a look at that, you can take a section line, come through here to here, and there's a fall of maybe 13.5 meters down to say 11, so it's about 2.5 meters of fall. It's quite a lot of fall. Okay, so how do we start? Well, first of all, we look at the boundary. So go back to select up here, and you can see this selects the boundary here, right? So the boundary could just be a pad. It's currently a boundary. Make the pad again. You use as boundary, then you drape on the ground, and that means that it's fixed at those points and along the line to the boundary. So you can see the elevations there, 14 meters, 10 meters, and so on and so forth. So that confines whatever happens inside, so it doesn't go outside the site boundary to the neighbors, although the survey might be larger. So the first thing we want to do maybe is just start at the bottom here at the access way. And you'll notice this line work is not connected to the line work here. And that's purposeful because Civil 3D users know, and 12D users, Bentley, it's not truly 3D, it's 2.5D because you can't have two Z values at the same XY value. So there's usually an offset, as you'll see as we go here. But if we take this point here, we can drape to existing ground like that. Just put the cut and fill on just so you can see this. We drape this to the existing ground. So what we're saying is that the elevation along here, you can query this as well. There's a query button somewhere. Here we are. So if I click this on my grid right now, maybe I should start with the settings. We've done our site settings, topsoil strip. We'll put that to 3, contour intervals 0. We'll leave that. It's snapping, so we'll get rid of snap for now, and we'll do the design grid to 0.2 meters. There are contour labels as well, so you can see elevations there, but I'll switch those off for now. So if I query the position of the land using the query tool, maybe just some random spot like on the boundary here, it'll tell us it's 10.182, it's 10.19, so it's about the same. So that's fine. As you can imagine, you drive over the site boundary onto the site. And now what we want to do is change these lengths. So here you can change the length. I'll just get rid of settings here as well. You can change the length of this, or the the grading of this line. So obviously 45% is too high for a car to enter, but we'll set it at 10, and we'll do the same thing over here. I'll click on this one and set that one to 10, and that's pretty steep ramp coming in, but we'll use that for now. And then we just work our way through here. The green means that that's the starting point, so they can be reversed. You can click on that. You can also click on the node point, click on the string, and it changes it back how it was before. We'll open the doors, they'll swing open, so 2 or 3% is not too bad, but we'll work with that for now. So if we start on this side again, you can see that's the wrong end. If we want to hold that point, so we just click on it, click on the string, it'll change it. And this one again, we want maybe 2.5% here as well. Gets into that top corner, and then we've got the top of the site to work on. So the building pad itself is currently at 12.63. I will change all that to 12, all corners. I'm not sure if I set the batter for these as well, so we can set the batter. I'm currently on the car park here. So the batter is 3 here, and then also the batter for the pads, we'll say is 3 as well, all right? Usually that's geotechnical input to determine what's the steepest batters before you move to retaining walls, as we're going to see. So that's 12. Clicking on the pad here, you can see for entry here, the best place to come in would be at the top of the site. So they'd park up, walk in at the top, because that's where the grades meet. Really, this area is going to have to be retained. You can see it's currently at 11 and this is 12, so people aren't going to be able to enter here unless you put steps, so it's better to have them enter here. And as I said before, you've got 2 lines that are not in the same place, because you can't have 2 z values at the same xy coordinate. So that's the reason. So if that's 12, this needs to be 12 as well, just to kind of match it as it works across. So I'll change that to 12. And then let's see, we have a 6% slope. If we look at that in 3D, just out of interest, you can see that's going to be difficult to enter. So I mean, what you could do is you could create another break line there, and then have that as 12 and make that steep coming up. But we can make this one a little bit steeper, and then this will get rid of how steep it is along the side. So there's this line I want here. Okay, good. Set this one to 2.5%. Okay, now that's a reasonable 2%, and that's easy enough to kind of work out minor grading in this area to solve that one. Pretty happy with that. And you can see the car park here showing 2.65. So we just have this corner here to sort out. It seems to be very deep in the cut, and there's 1%, so there's an opportunity to raise this. So maybe I should work from this end. We don't want to change this one, so we'll hold that, and then we'll set this grade. Let's call it 2.5% as well. And that's pretty good. The reason that green line is showing there is because the main boundary pad, if you had it set to 0.15 strip, then it needs to be 0.1 fill as well, so that gets rid of that. You can see here at some point retaining walls are going to have to come in, because this is very close to the boundary here. Not going to work. So first of all, you can check the section. Let's just have a little look through here first, and you can see the grade is pretty close to flat, so that's probably safe enough to work with that and not change it. But down here, we're going to have to introduce retaining walls. So how do we do that? Well, you select the line that you want. You can see here the grade is in fill, and you can see at this point the fill is going to go over the boundary. So this is where a retaining wall would typically come in. So you can add a retaining wall just randomly. You can just click anywhere and it will create it. The other way to do it is to give it an offset from a position. So for example, if I wanted to select the line again, set this as the point to start with, click on the line I want, and then from here it says add from, so if that's 33 meters, maybe this is say 12 meters. Let's try that. 12 meters, add, and there is the line. Okay, so there's 2 ways of doing it. For now I'm just going to randomly click on it. So click add, go to here, and I would say somewhere around there will do. And then you can see this is going to come around here, this retaining wall, and then it's going to come to somewhere here. And again, that's also can be infilled, so we can put it there like that. And then all we have to do is just select the strings that we want as retaining walls, and you click on this button, retain this edge, instead of battering it. and that's that one done. And then select the next one, so here, and retain that one there. All right, let's look at that on 3D. Yeah, now you can see it kind of looks like a cleaner line. And you can see then the fill kind of spreads past the wall. There'll be a small return there on that wall to kind of hold that, or it can spread just depending on how you do it. Okay, we have to do the same thing over here. This is in cut, and the cut is too far into the neighbor's property, so we're going to introduce some more retaining walls. So we can select on the pad, add, I would say somewhere around there, and also somewhere just around the corner from this. Same thing again. Select the string that you want to create into a retaining wall. Select this little string here just to bring it around that corner, and that's that. It says the cut and fill over here is balanced, but that's because we haven't included the fill below the slabs because it's based on finished grade. But we have to subtract off the layer works for the car park and then the building slab and maybe a base course below. So let's do that now. So select the building pad, construction depth. Let's say the slab's 150 and the base course is another 150. Let's select the car park. Let's do the same thing, 0.3. And now the cut is 700. I'll just get rid of the section line. It's not really helping us very much. So you can see now the cut is 770 cubes and the fill is 220. So we're going to have to cut to waste 551. That's pretty good in terms of the grading. And you've got a few retaining walls. The grades are a little bit tight here, but for the most part, it's pretty good. What you can also do is you can change the colors to kind of make it look visually a bit nicer if you wanted to. So we click pad fill, and you can kind of get a sense of what colors everything is. So maybe we'll change that building slab again to a more realistic looking color. That's better. And the car park, change that to that, back to 3D, and you get a sense of what's happening there. Okay, so that's the modeling pretty much done. So let's just see what other things we can do here. So we've done that. There is a section for rates. So if you know how much it costs to cut and fill, you can put that in. You can also put in your cut to waste if you know how much that costs, import to fill, and then walls. So it's picked up automatically what height the wall is. I've got rates just here to demonstrate how this works for 1 meter high and then above 1 meter. And that's really where the money is. So you can see right now there's a $60,000 worth of work based on these rates. And obviously I can input a lot more rates. I can also reduce the retaining wall lengths because they're working from zero, but the reality is you might use a curb in some areas rather than kind of heavy retaining, or you might split it between walls 0.5 meter to 1 meter high and so on and so forth to try and break that down. But in terms of a quick concept, it's pretty good. So in terms of exports, what it's going to give you is a couple of things. It's going to give you land XML for Civil 3D. You can also use it for another solver called the volume solver to compare that against your existing grade. And then there's also DXF, which will give you all the contours. So we can just click on a few things here. In terms of land XML, it will give it to you in finished surface as vertex tin, which is triangulated irregular network, which is used in Civil 3D. So what happens there is that should look exactly like how you would see a normal tin in Civil 3D. For those of you who don't have Civil 3D, that surface is also can be used for the volumes. But for the non-Civil 3D users, if you just click DXF, it sends you the file. You can click on your land XML as well. It'll give you that. As I said, if you unclick this button, it will give you a grid version of the surface. If you're in the middle of the job, you want to come back, then you can save the job as well. That's a possibility, and that will work as well. And you also have the help file as well. Okay, so here you can see the exported DXF, which gives you the different elevations, the contours, and the same line work that you started with. And here is the model in Civil 3D. You can see if you look for Object Viewer here, you can see it's done a pretty good job of the returns on the retaining walls, where the cut and fill ends, how it intersects at those changes in height on the slab, the building slab, and that's a fairly typical surface, and that's worked quite well. And that's it. Next one will probably be a volume solver, which allows you to compare the two surfaces and generate a typical heat map or comparison surface and export that to DWG as well. And sometime in the future as well, maybe a part solver would be good. That will allow you to connect assemblies like curbs, retaining walls to the string or feature lines. In the meantime, you can check out the Topo Solver video in this channel.